Well, good morning, students. Welcome to Monday, April 13th, 2020. I hope you had a nice spring break. Hope you had some time to get out and enjoy. We had a couple nice days of weather. I know I spent some time out in my yard, got some things done, spent some time doing schoolwork, trying to catch up. Some of you need to do some of that. What we're going to be doing next. Oh, forgot to turn on my board. Just a second here. Alright, we're going to be starting a new unit. Unit 6 is going to be on earthquakes and volcanoes. And what we'll do is we'll split that into two portions. In the past I had done it as one bigger unit, but I'm finding that, it works better with a lot of students if we take smaller chunks at a time. So we're going into earthquakes right now. All right, so here's our learning targets for today, April 13th. I can name and define different types of stress in the earth. I can explain the difference between plastic and elastic deformation. I can define and use basic vocabulary terms associated with earthquakes. Those are the things that I want you to be able to do. So, let's talk about stress. Now, with our whole situation and learning from home, remote learning, and a lot of people you hear on the news all the time talking about our stress. That's not what we're talking about here. We're talking about stress in the earth. So in geology, geo, remember, means earth. So in the study of the earth, stress refers to force being applied to rock. Okay? Now as we go through things, I am expecting you to take notes. So if you started watching this and you don't have your notes in front of you, stop, get your notes out. Now, you got your notes out. We got vocabulary terms. Stress. The word stress refers to forces being applied to rocks in the earth. There's different types of stress. So the first type is going to be called compression stress. Again, I expect you to get these definitions down. In compression stress, forces are squeezing together. Rocks are being compressed, squeezed together. What happens is the rock ends up getting bent and folded. So, as an example, I have this old, ugly sponge here. But let's imagine I just apply a force pushing it together. And you see it's crinkling and bulging and bending and folding all together. That's the result of compression stress. Now, it's a little hard, I think, for some of us to imagine this happening to rock. But rocks are under incredible forces and pressures in the earth. And those forces literally kind of wrinkle up the rocks at times. And I had shown you, I should have probably found it again, but I showed you a picture much earlier in our class here, a series of pictures, and some of them had rocks that have been, you can see where they were bent and folded and mangled. Compression stress is one of those things that does that. So compression is squeezing together. Okay, another type of stress is tension. Tension is when forces are pulling apart. So imagine I clamp onto this end of my rock and I clamp onto this end of the rock and I pull. And the rock is getting stretched. It's under a different kind of stress. And you can imagine that if I apply enough force, enough tension, I'm going to rip that right in half. Could break rocks. This is common at divergent boundaries, where plates are pulling apart from each other. So, tension refers to a pulling force. Compression refers to a squeezing force. All right, next one, shear stress. Shear is where forces are parallel to each other, but either they're moving at different speeds or they're moving in opposite directions. and it's common at transform boundaries. So let me take two pieces of foam, and let's say they're touching each other, but this piece of foam is going to move upwards while this piece of foam is trying to move downwards. And so we get a shearing stress. Now, let's think about other words that you know. You probably know this is called the scissors. But sometimes things like this, or devices like this, are called shears. And if you think about it, what's happening with the blades? One piece of blade is moving past the other one, or the two blades are moving in opposite directions right next to each other, and they're shearing. They're moving just past each other, but along each other. Okay? They're not moving directly at each other. Here's a tool where the two sides come moving directly at each other, and so, you know, right in here I could squeeze my finger and I got compression. Don't try this at home. You know, in here, if my finger were in there and I put together, I'd be shearing. And you can see that there's a difference between compression and shearing. So in compression, the things are coming directly at each other and squeezing. In shearing, they're sliding past each other and cutting through. So shear stress is common at transform boundaries. All right, we got one more. It's called confining stress. And I think this is the hardest one to kind of visualize and understand. It's not the one that we're going to talk about very much in our classwork. But if you have rock that's buried deep within the earth, it can be under a situation where it's being compressed, but it's being compressed from all sides. So when we were talking about compression, we were basically talking about forces moving at each other. But what if the forces are not only moving this way, but they're this way and this way and this way and this way, and it's being confined and squeezed all around? And it could result in some changes to the rock, but it's a little different from what we had. So think about it's being squeezed from all sides, all directions. It's confined. All right. So now, when you apply this stress to rocks, they can either become deformed, which changes their shape, or they might break. Okay? We're going to talk about a couple different types of deformation. So, first of all is elastic deformation. And you think about elastic properties. Imagine a rubber band. If I stretch the rubber band and I let it go, it wants to snap back to its original shape. That's what elastic really means. It wants to bounce back to its original shape. If you are dribbling a basketball, when you push the basketball towards the ground, it hits the ground, that ball gets compressed against the ground, but then it springs back. It's elastic. It wants to go back to its original shape. So, as an example of elastic deformation, okay, I just have a stick here, and if I apply some force, you can see that I bent the stick, but I let the force go and the stick's back to its original shape. I can bend it, it's deformed, but it wants to go back to its original shape. It's deformed, it goes back to its original shape. So elastic means it wants to spring back. Plastic deformation is when the rock doesn't spring back when the stress is removed. Okay? So, I have a piece of, it's called shelf plaster. It's one of these things where you put it on inside of, say, a bookshelf, and you have the little shelf hooks that you put in here. Now, if I apply a little force to this, you see it's bending, but when I take my force away, it stays bent. Alright, so I kind of more permanently changed the shape. It didn't spring back to its original shape. So that's called plastic. You know, if you take a piece of plastic and you heat it up, melt it, squeeze it. You can change its shape, but then it keeps that new shape. Okay? Now, when we go back to these deformations, in particular this elastic, and you say, oh, I bend the stick, what happens if I apply too much force? Well, I'm going to take this ruler that somebody has already broken on me, and we see that rulers go through elastic deformation, right? You can bend it and they want to go back to the original shape. But if you bend it, boy, we can bend that quite a ways. But if you bend it too far, it eventually fractures. A fracture is when the rock breaks. Note, this ruler was already broken and I used it for a class demonstration. That doesn't give you permission to break more of my rulers. So, let's get some terminology. What is an earthquake? It's a shaking of the ground due to movements within the Earth's crust. Okay? You could, sometimes, you see, it refers to crust, sometimes you see lithosphere, but earthquakes always happen relatively close to the surface of the Earth. And they create a quaking, a shaking. Okay? The word seismic relates to vibrations traveling through the Earth. So it's earthquake vibrations, big bombs. There are things that cause vibrations in the Earth. Literally, if I go stomping my feet, I'm creating vibrations in the Earth. Those are seismic phenomena. All right, what's a fault? A fault is where we have a break or fracture in the rock of the Earth's crust. So it's not just a break or fracture, along which there is movement of the rock relative to the other side. So, if I got a crack between two rocks, that's not necessarily a fault. But if there is forces in the Earth causing movement along that crack, that's called a fault. So, all faults are cracks, but not all cracks are faults. Okay? There's got to be some movement, right? So we have plate tectonics happening. We might have a shear stress along a transform boundary where two pieces of earth are moving past each other. That's a fault, okay? If you just have a rock that's broken in two pieces, but there's really no force being applied to either half, that's just a broken rock. All right, so when an earthquake happens, you've got pieces of earth that are in contact and they're under some sort of stress and they build up. When the stress gets too great, all of a sudden they move. Okay? The entire fault doesn't move at the same time. So the focus is the actual point in the crust where the movement took place. Okay? This is down in the earth a little bit, in the crust or lithosphere, where the movement occurs. Now, when you watch the news and they talk about an earthquake, they always refer to the epicenter. Okay? The epicenter is the point on the surface of the earth directly above the focus. So down in the earth, we had some movement, and up on the surface, that point directly above it, that's the place that's going to notice the earthquake first, because it's the closest to where the earthquake actually happened. That's called the epicenter. It's on the surface. When an earthquake happens, you get this stress built up and it moves. It might move just a little. It might move a lot. The amount it moves is called slip. How far did it slip? So it says the relative displacement. I know that's kind of a sciencey word, but we're talking about the relative motion of the material on opposite sides of the fault. How far did it move? Now, something to keep in mind is on the surface of the Earth, if you're standing on this side and I'm standing on this side and the Earth moves, we really can't tell. If you're standing over here, it might look like the other side moved, and if you're standing over here, it might look like this side moved. We really can't tell necessarily which side moved. It's relative motion. We know they moved relative to each other. So if we do a quick little vocabulary check, I got a diagram. Here's the surface of the Earth. Wonder what this line coming down here, that's labeled A. So right now, I want you to think about what would you call A? Hopefully, you came up with the word fault. That's a crack in the Earth. That's what I'm trying to show here. Okay? Now, I'm indicating that something happened right there and it sent out this energy at point B. And you should be thinking about, what do we call point B? I hope you came up with the word focus. B is the focus. That's where the actual slip took place. C is on the surface of the Earth, and it is directly above our focus. Think back, what's the term for that? Hopefully you came up with epicenter. So we have a fault where the earthquake happens in the Earth is called the focus, and the point on the surface directly above the focus is the epicenter. A couple more terms yet. I don't know exactly where some of these words come from. They're interesting words. Dip. Dip refers to the angle between a fault and a horizontal. So if this is the surface of the Earth and we got a crack going down in the Earth like that, this angle between that crack and horizontal is called the dip. Okay, so if the crack went straight down into the Earth, the dip would be 90 degrees. If the crack is at a slight angle, or goes like this, then that would be a smaller angle. Within an earthquake now, or along a fault rather, I should say, we have two different slabs of rock that are moving relative to each other. Okay? And they have different names. This one's called the footwall. This one's called the hanging wall. How do you determine that? Well, let's imagine we had a tunnel that was directly on the fault. And we have our little guy standing in our tunnel. Where are his feet? His feet are resting on this slab of rock. That's the footwall. That's the slab of the rock beneath the fault. Okay? Where does the guy hang his lantern? He hangs his lantern from this slab of rock, which is called the hanging wall. Okay? The hanging wall is a slab of rock that's above, and the footwall is below. Now you can imagine if the dip was 90 degrees, I don't know how you determine that. But typically, I guess these faults in the Earth aren't going to be necessarily directly 90 degrees. So the one that's lower is called the footwall. The one that's above is called the hanging wall. All right. So I got one more diagram here. And the goal of this one is for you to try to fill in what is A, what is B, what is C, what is D, what is E, what is F. And I'm going to give you some sort of a Google form or something, you check in your assignment that you are to fill out A, B, C, D, E, F. Preferably without looking back at the notes you just took to see if you remember any of them, right? So, that's as far as I'm going here for today. Thank you for watching. Stay safe. See you tomorrow.